Hello everyone, welcome back to my YouTube channel Learn Together 2026, and today we will learn about chapter number 2, acid, bases and salts. So let's move towards the topic, but before that I would like you all to like, subscribe and comment on my channel. Let's move towards the topic. Acids. Acids are the substances which donate proton in water. Okay, so if you see what is the meaning of proton, proton means H plus ions. Okay, H plus ions when donated by a substance in water, that is known as acids. Okay, there are several more properties. Sour in taste, like if you have tasted lemon, so whatever the taste of lemon is there, that is the exact taste of acid. It can cause blue litmus paper turn into red litmus paper, and it is also corrosive in nature. If the examiner asks you about the examples, then it is hydrochloric acid, vinegar, lemon juice and many other acids are there. What is the pH scale? Whatever the pH scale acids have is from 0 to 6.9. Okay, and what if the blue litmus paper changes into red? This is shown in this figure, that we have taken blue litmus paper and as soon as it touches the solution it becomes pink in color. Okay, so these are the properties of acids. Now we will move to the next slide. Types of acids. There are three types of acid based on the strength, concentration and source. So first we will go for based on strength. Based on strength, we have two types of acids, strong acids and weak acids. Strong acids are the substances which completely ionize, right? If they are going to have 10 H plus ions, so they are going to give all their 10 H plus ions into water. So these are known as strong acids, whereas weak acids, if they are going to have 10 H plus ion, so they will give only 2-3 H plus in water. This is said to be weak acids. Okay, let's move to the next slide, that is strong acids. Obviously examples are there: HCl, HNO3, sulfuric acid, hydrobromic acid, hydroiodic acid, perchloric acid, chloric acid. Whereas weak acids are generally organic in nature: oxalic acid, sulfurous acids, phosphoric acid, nitrous acid, benzoic acid, acetic acid and formic acid. Okay, so these are the examples that can be asked by the examiner. Now, based on the concentration, there are two types of acids: dilute acid and the other one is concentrated acids. Okay, dilute means if you have ever prepared sugar solution, then in that case sugar is more in concentration, whereas water is less in concentration. That reagent or that solution is known as concentrated acid, concentrated solution. Whereas if you are preparing for any lemonade, then you will add a very small amount of sugar and very large amount of water, that is said to be dilute substances. So in the case of acids, if the high proportion of water is there, then it is said to be dilute acid, and when the proportion of acid molecule is high, that is said to be concentrated acids. Dilute acids are less aggressive, concentrated acids are very aggressive, very corrosive. Okay, now let's move to the very important thing. If you want to dilute a concentrated acid, then what we are supposed to do, we will add water in it, right? But there is a specific way proposed the uh, by the scientists, that we will never add water to acid. It is really prohibited that we cannot add water to acid, because acids cannot absorb the excess heat produced or absorbed by the solution. Okay, so in this case the beaker can blast, or you can face any of the casualty. Whereas if you are going to add acid to water, water is a good absorber of heat, so whatever the reaction is there, it is highly exothermic, so this heat will be absorbed by the water only, it will not radiate towards the beaker. So you are in safe hand if you are going to add acid to water. Okay, let's move next, that is based on source. So there are two types of acids based on the source. One is organic and the other one is inorganic acid. Organic means if you are using any of the animal or plant product, that is said to be organic, and if you are using any artificial product, that is said to be inorganic acids, right? So in this case, whatever the acids which are produced from any of the living things like fruits or plants or animals, they are known as organic acid, whereas those which are prepared in labs are known as inorganic acids. For example, hydrochloric acid and sulfuric acid. Now let's move towards the next topic. There are few more examples like vinegar, apple, milk, ant is having formic acid, and this is very important for your board exams, and oxalic as well because it is present in tomato. Milk has lactic acid, apple has malic acid. So these are very important examples. You have to make sure that these cannot be missed at any cost. Okay, let's move ahead. Reactions given by acids. So generally acids react with water, and this dilution is very exothermic reaction, so we have to add acid slowly into the water. Dilution will decrease the H plus concentration and the reaction will produce hydronium ion. The formula of hydronium ion is H3O plus. Okay, so this is the dilution of acid. Now move towards the next, which is very important. If you add any acid to the metal, it will produce hydrogen gas, and this gas is identified by the pop sound. Okay, so in this case the pop sound will be coming out, and you will be identified this as a reaction of metal with any of the acids. Okay, very important reaction. Now next move towards the metal carbonates. Whenever you add the acid to the uh, any metal carbonate means Na2CO3, K2CO3, CaCO3, like when metal is attached with carbonate group, then it is said to be metal carbonates. Okay, so in that case the salt is the whatever the salt is there, it will be produced in the same way, but the excess product will be H2O and CO2, and the identification of CO2 gas is, first effervescence will be there, and second is that it is going to turn lime water milky. Turn lime water milky is the identification of CO2 gas. Okay, so this is one question that can be asked in any of the exams, in which they will tell you that uh, any substance reacts with uh, acid, and it is going to produce a gas which will turn milky lime water milky. So in that case you have to identify that gas as CO2 gas. Okay, let's move to the next topic, that is reaction with metal hydrogen carbonate. Hydrogen carbonate means whenever the substance is going to have HCO3, this HCO3 is known as hydrogen carbonates. So in this case you will get the same product as we have studied earlier, but in the previous reaction we have to balance the reaction, but in hydrogen carbonate case we don't have to balance the reaction, it is automatically balanced, but the product will be same as the metal carbonates only. when acids are going to react with metallic oxides, then just because metallic oxides are basic in nature, so acid and base are going to give salt and water, and this reaction is known as neutralization reaction. Okay, next is the bases. Bases means, as you know that acids are going to give H plus ions, bases are going to produce OH minus ions in water. So this is the identification of base. Bases have a bitter taste, slippery feeling, like if you have touched the soap, whatever the slippery touch is there, it is same with the bases. It turns litmus paper blue. I'll show you the picture in which you can identify the difference, and examples are sodium hydroxide, baking soda, ammonia, and the pH level of bases is 7.1 to 14. Okay, let's move towards the next picture. This is, you have seen this red color paper, this is the litmus paper, but but when it entered the base, it turns into blue. This is the nature of base only. Now let's move towards the reactions given by the bases. Bases are going to produce OH minus ions, and they will decrease the OH minus ion on dilution. Okay, they can conduct electricity because they have negative charge, so they can conduct electricity. If you are going to react a base with any of the active metal, active metal means zinc, aluminium, copper, these are the active metals. So sodium zincate can be form a mixed salt, as well as hydrogen gas is also produced, right? The last reaction given by bases is, if you are going to react base with a non-metallic oxide, it will give you salt and water as per neutralization reaction only. So these are the very important reactions given by bases. I hope you have taken the screenshot of it. Okay, let's move to the next topic, that is indicators. Very important topic of this chapter. There are three types of indicators. First is olfactory indicator, second one is synthetic indicator, and the third one is natural indicators. Okay, now there is one line definition that olfactory indicators are the substances which turn their smell, like whatever the smell they earlier have, they might have lost it or they have gained it. It is something like that which change their smell, so they are known as olfactory indicators. Very famous examples of olfactory indicators are onion, vanilla essence, and clove, right? Synthetic indicators are the indicators which are man-made chemicals that show change in their color when they are put in acidic or basic medium. So they are basically phenolphthalein and methyl orange. And natural indicators, as per their name, natural indicators are obtained from the natural sources, and they also change their colors in acidic and basic medium. Very important is litmus, which is obtained from lichens. Second one is turmeric, and third one is China rose, right? So let's move towards the next topic, that is pH scale. Very important topic. The pH scale is a numerical scale, like we all are having our scale in our pencil box, that is of 15 centimeter, but this scale is only starts from 0 to 14, and it is used to measure the strength of the solution. It will tell you whether the solution is acidic or basic in nature, depending upon the number of H plus ions present in the solution. So children, if it is pH is more than less than 7, then it is said to be acidic. If pH is equals to 7, it is said to be pure water or neutral. If pH is more than 7, it is basic or alkaline in nature. So basically the concept which arise from this: lower pH high acidity, higher pH higher basicity, right? So this is the case of pH scale. Now move towards the next thing. This is very important for you because there are certain examples which can be asked from this picture only. uh, 2 pH is of lemon, tomato is having 4, coffee is having 5, milk is having 6, almost neutral. But water is the only substance that is completely neutral. blood is basic, egg white is obviously basic, stomach tablets, whatever the tablets we use during acidity, whenever we suffer from acidity, those tablets are basic in nature and they help us to neutralize the excess acid present in our stomach. Ammonia solution basic, soap is basic, bleach and drain cleaner all are basic in nature. So kindly make sure that this uh, picture should be in your mind whenever you are going to give your science exams. Okay, and now move towards the next slide, that is salts. Salts are basically the neutralization reaction happened between acids and bases, and they are going to produce salt and water, right? The general equation is acid plus base give us salt and water, and the very easy example is HCl plus NaOH gives out NaCl and H2O, right? Now let's move towards some important examples of salt for our CBSE board students. The first is bleaching powder, sodium hydroxide, baking soda, washing soda, plaster of Paris. And mark my words that any one of the question is surely going to come in which baking soda is very important and plaster of Paris is very important. But I'm not saying that these three are less in number. They can be as, but baking soda is very important for CBSE board exams. So let's move towards bleaching powder. Bleaching powder is prepared when calcium hydroxide is passed through chlorine gas, and the other name for calcium hydroxide is slaked lime. Okay, it is going to give CaOCl2. This is known as bleaching powder, and along with water, physical properties is pale yellowish white powder, a strong smell of chlorine, and it is partially soluble in water. The chemical properties is that whenever you mix bleaching powder with water, it releases chlorine gas. It is a strong oxidizing agent and it liberates chlorine gas. The use of bleaching powder is a very versatile disinfectant, bleaching cotton cloths and linen, and the last one is as an oxidizing agent. Okay, now next is our sodium hydroxide. Sodium hydroxide is prepared by the electrolysis of brine, and I hope you all know what is the meaning of brine. Brine means when NaCl is mixed with water, the solution is called brine. And just because in this process we have got an alkali and chlorine together, this process is known as chlor-alkali process, right? In this, NaCl mixed with water gives NaOH, chlorine and hydrogen gas. Sodium hydroxide is white solid, slippery to touch, highly soluble in water and strongly alkaline, approx having the pH of 13 to 14. The chemical properties are it neutralizes acid, gives salt and water, absorbs CO2 from air, and reacts with metal like zinc and aluminium. The uses of sodium hydroxide is the manufacturing of soap and detergents, paper and textile industry, used as drain cleaners. Okay, let's move towards the next salt, that is baking soda, very important. And in baking soda, the process of preparation is ammonia soda solvay process, in which you used NaCl with ammonia, water and CO2, then mix together forming NaHCO3 and ammonium chloride. Ammonium chloride is the byproduct and NaHCO3 is the baking soda, right? It is white crystalline powder, mild alkaline to taste and soluble in water. And baking soda you all have used whenever your mother cooks any bhatura, and if she boils anything, then also she use baking soda. Okay, now chemical properties, on heating, baking soda gives a washing soda. When reacts with acids produces CO2 gas, and the use is it is a baking agent used in fire extinguishers and used as antacids. Antacids are the tablets which are used when you feel acidity, right? Next is our washing soda. Washing soda is prepared by heating baking soda, obviously the previous reaction. And whenever we hydrate washing Na2CO3, we get washing soda. Physical properties: white crystalline solid, efflorescent in nature. It means it absorbs the moisture from the atmosphere, and it is also soluble in water. It is alkaline in nature. Softens hard water, means whenever you add washing soda to hard water, it gets converted into soft water. It neutralizes the acid, used as cleaning agent. Washing soda obviously used for cleaning agent in your detergents and all those things. It is used as a hard water softener and used in manufacture of glass and soaps, right? Now moving towards the last salt, that is plaster of Paris. It is prepared by heating gypsum. The gypsum is CaSO4.2H2O, and approx the temperature will be 100 to 120 degrees Celsius. Do not exceed with the temperature, otherwise the plaster of Paris will lose its water of hydration, and then it will convert into a hard mass which cannot be converted into any of the structures. So it will prepare CaSO4 dot half H2O plus 3 by 2 H2O is left over. Okay, physical properties: it is a white fine powder, smooth to touch, sets quickly with water. You all have seen false ceiling in your home. This is just because of plaster of Paris. Now chemical properties: it sets with the water and gives gypsum again. Exothermic reaction during settling. Okay, it is used for making cast for fractured bone, making molds for statues, and decorative material and toys. So I hope you all have understood the chapter, the gist of the chapter, acid, bases, and salts. Thanks for watching. Keep like, comment, share, and subscribe my channel. Thank you. Have a